Now we got angle bisectors. Angle bisector is a ray that divides an angle into two congruent angles. Remember, congruent means equal. I know that they're congruent because they have these red arcs right here and right here. That means that they are the same. So that kind of tells me that LN, this ray, bisects the big angle. So it cuts it in half, so these two are the same. Congruent. So it says if LM bisects angle JLN, first I'm going to draw that. Angle JLN, and then it says LM bisects. It says, the second it says bisects, I know these two angles are the same. Okay? Then it says JLM is 42. What is JLN? So it wants to know the big angle. That's what we want to find out. Well, if JLM, this angle, is 42, I know that this angle, MLN, is also 42, because they're the same, remember? If I want to know the big angle, all I have to do is add those two. 42 and 42, angle JLN, 84. Okay, so bisects, cuts in half. Then we kind of use the segment addition postulate, saying that the two smaller ones make up the bigger one. So kind of putting it all together. Adjacent angles, there's a bunch of them. Angles that are next to each other. I'll say angle 5 and angle 6. There are tons of other ones. 4, 5, 3, 4, 2, 3, blah, blah, blah. Vertical angles. They need to be made of the same lines. So, for example, if I use these two lines, the only two lines, I have these two angles that are vertical, they're opposite, across from each other, 2 and 6. I also have 1 and this whole angle that doesn't have a number, so I'm not going to use that one. But those are the two vertical angles in that diagram. Complementary angles, remember that makes 90. Here we have this fancy little sign that calls 90, and so the two that make up that big angle, right here at right angle, is angle 4 and angle 5. That's supposed to be an and sign. That's horrible. Supplementary angles. Supplementary adds up to 180. Again, there's a lot of them. What I like to do is just pick a line. So I'm going to pick this line right here. I only want 2 angles, so I'm going to go with 1 and 2. That'll give me 180 degrees. You could also go 1 and 6. And I think as far as 2 angles, all of them, I think. And the last one, linear pair. Again, kind of the same thing as supplementary, but linear pair requires them to be next to each other. Supplementary doesn't. And this diagram is kind of the same thing. So since 1 and 2 are next to each other, I'm just going to go with them again. And same thing with 1 and 6. Let me know if you don't understand the difference between linear pair and supplementary. In my opinion, they're kind of the same thing. Just that linear pair requires them to be next to each other and supplementary doesn't. Alright. We have a diagram. It says given the measured angle 2 equals 7x plus 4, and measured angle 6 equals 5x plus 10. Solve for x, and we gotta justify again. So angle 2, this angle right here, and angle 6, this angle right here. Well, coincidentally, I think we named those two in the last one. Those are vertical angles because they're made up of the same lines. What I know about vertical angles is that they're the same. So I got the measure of angle 2 equals the measure of angle 6, and I know that my justify part because of definition of vertical angles. And then just like we've been doing, I gotta substitute. Angle 2 I know is 7x plus 4. Angle 6 is 5x plus 10. Substitution. Don't write just sub, because that could be subtraction, substitution. I don't know what you're talking about. Then we're going to subtract. Oopsies. 2x plus 4 equals 10. Subtraction. We're going to go into the other page. That's okay. Subtract again. 2x equals 6. And division. My x will be 3. Doesn't ask me to plug it back in, but I could ask you that as well. So, hopefully those are getting a little bit better. And on the bottom, it says given the measure of angle 3 and the measure of angle 6, solve for x. So up here, I got angle 3 and angle 6. Those are the two angles I'm looking at. I really shouldn't be putting those marks. They're not the same, but those are the angles that we're talking about. Okay. This one's gonna get a little bit longer and more complicated. Just follow along, rewind if you need to, and definitely ask questions. So I'm gonna kind of start with the last one. I'm going to say that the measure of angle 2 equals the measure of angle 6. Okay, 2 and 6, remember those are vertical angles. So I'm going to say definition of vertical angles. Okay, then I'm going to kind of erase this picture for a second. I know that since this is a right angle, I know that this is a right angle. So I know that 2 and 3 are complements. They add up to 90 degrees. So I'm going to say measure of angle 2 plus the measure of angle 3 equals 90, because definition of complementary. You can't even read that. That's okay. Alright, so now you can kind of see why I started with the definition of vertical angles. I have measure of angle 2 here and here. Well, if measure of angle 2 is equal to the measure of angle 6, they're equal, I can just kind of switch them in for each other. So just like we've substituted for putting in x's for measures, we can substitute measures for measures. So I'm going to do that. Put measure of angle 6 plus the measure of angle 3 equals 90. And that's just by substitution. Okay, and then now we are just to where we've been before. Measure of angle 6, 2x plus 12. Measure of angle 3, 3x minus 2. And that is substitution again. And now we're just going to simplify. 5x plus 10 equals 90. And then we're going to subtract. So 5x equals 80. 80. Subtraction. And x equals 16 by division. It only asks us to find x. So that's all we're going to do. All right, last slide. It says for exercises 8 through 11, can you make each conclusion from the information in the diagram explain? So it wants to know, is CEG, so CEG, so this angle here, is it congruent to FED? FED. angle here. Congruent, are they the same? Well, I look, this is a line, this is a line. That makes these the same because they are vertical angles. Okay, number 9 says, is DE from here to here congruent to EF, here to here? These little hash marks tell me they are. Those hash marks, just like the arc marks, tell me that they are congruent. So yes, and then we'll just say they are marked. Hopefully that makes sense. I'm going to erase this part here. 10 says angle BEC, or I'm sorry, BCE. So BCE, this angle here, is that congruent to BAD? BAD, this angle here. Nope. Or at least we can't say it is. I'm pretty sure they're not, but so far we can't say they are. They're not vertical angles, supplementary, complementary, you can't say anything like that. And then the last one, angle ADB. So ADB, this tiny one, and angle FDE. FDE, are they vertical? Well, vertical, I always want to check lines. So I got this line, and I got this line, and sure enough, FDE is right here, and ABD is here. They are made up of the same lines. So yes, they are across, opposite, made up of the same lines, whatever you want to say. And that is it for lesson 5, and I think the entire primer section.